Let's dive into the use cases for Cloud PubSub. Cloud PubSub enables your application to perform operations asynchronously. Traditionally, one service or component of your application has to directly invoke another component to perform an operation. The call is synchronous, so the caller has to wait for the entire operation to finish. The application components are tightly coupled because both must be running at the same time. With Cloud PubSub, you can design your services to make asynchronous calls and be loosely coupled. For example, in the diagram, the order service acts as the publisher. It publishes messages that contain order information to the orders topic and returns immediately. The inventory service acts as the subscriber. It might even be down when the publisher sends messages. The subscriber can start running a little later and process the messages it has subscribed to. Cloud PubSub enables you to use a topic as a buffer to hold data that is coming in rapidly. For example, you might have multiple instances of a service generating large volumes of data. A downstream service that needs to process this data might become overwhelmed with the high velocity and volume of data. To address this issue, instances of your data generating service can act as publishers and publish the data to a Cloud PubSub topic. Cloud PubSub can reliably receive and store large volumes of rapidly incoming data. The downstream service can then act as a subscriber and consume the data at a reasonable pace. Your application can even automatically scale up the number of instances of the subscriber to handle increased volumes of data. The diagram shows many messages with order information coming in from various sources. The inventory service can subscribe to these messages and process them at a reasonable pace as appropriate. With Cloud PubSub, your application can fan out messages from one publisher to multiple subscribers. Instead of being aware of all services that might be interested in a particular piece of data and making brittle point-to-point connections with all the services, the publisher can push messages to a centralized Cloud PubSub topic. Services that are interested in the information can simply subscribe to the topic. For example, in the diagram, information about orders is fanned out to the inventory and payment services. Cloud PubSub delivers each message at least once. This means that a subscriber can sometimes see duplicate messages. Implement your publisher and subscriber in such a way that the application can perform idempotent operations. The publisher can publish messages with a unique ID. Your subscriber can use Google Cloud Data Store or Google Cloud Bigtable to store information about messages that have already been processed. Use the unique ID as key. Whenever a message is received, the subscriber can check previously saved messages to see whether the incoming message is new and needs to be processed. If the message has already been processed, the subscriber can just discard the duplicate message. For use cases that involve big data, you can use Google Cloud Dataflow PubSub.io to achieve exactly once processing of Cloud PubSub message streams. PubSub.io removes duplicate messages based on custom message identifiers or identifiers assigned by Cloud PubSub. For more information about PubSub.io, see the Downloads and Resources pane. Cloud PubSub provides a highly scalable messaging architecture. The scalability comes with a trade-off. Message ordering is not guaranteed. Where possible, design your application to reduce or even eliminate dependencies on message ordering. For example, message ordering is not relevant in use cases where your application is collecting statistics about events. You don't need to process the statistics-related events in order. Similarly, if, say, 5 of your contacts come online around the same moment in time, you don't need to be notified about their presence in the exact same order that they came online. Then there are scenarios in which the final order of messages is important, but the order in which the individual messages are processed is not important. For example, log events with timestamps may stream into the logging service from various sources. The order of processing each log event is not important. However, eventually your system should enable you to view log events ordered by timestamp. Cloud PubSub works well naturally for use cases where order of message processing is not important. Finally, there are scenarios where messages must absolutely be processed in the order in which they were published. For example, financial transactions must be processed in order. Similarly, in a multiplayer online game, if a player jumps over a wall, lands on a monster, and recovers the lost jewel, other players must see the events in exactly the same order. You can implement ordered processing of messages in one of the following ways. In the first scenario, the subscriber knows the order in which messages must be processed. The publisher can publish messages with a unique ID. Your subscriber can use Cloud Data Store to store information about messages that have been processed so far. When a new message is received, the subscriber can check whether this message should be processed immediately, or the unique ID indicates that there are pending messages that should be processed first. For example, the inventory service knows that orders should be processed in sequence using the order ID as key. When messages with order IDs 103 and 104 are received, it checks the previously processed orders and determines that 102 is pending. It temporarily stores orders 103 and 104 and processes them all in order when order 102 is received. In the second scenario, the subscriber checks oldest unacknowledged message in Cloud Monitoring metrics. The subscriber can store all messages in a persistent data store. It can check the subscription/oldest unacked message metric that Cloud PubSub publishes to Google Stackdriver. The subscriber can compare the timestamp of the oldest unacknowledged message against the published timestamps of the messages in Cloud Data Store. All messages published before the oldest unacknowledged message are guaranteed to have been received. So those messages can be removed from the persistent data store and processed in order.